This is an RNZ podcast.
Kia ora, and a very big welcome to Elemental. This is a podcast journey through the wonderful world of chemistry. I'm Alison Balance, and I'm a science producer at RNZ.
And I'm Allan Blackman, and I am a professor of chemistry at the Auckland University of Technology. And the reason that we're making Elemental at this time is that it is the International Year of the Periodic Table in 2019, marking 150 years since the publication of the first periodic table.
It feels like about 150 years since I did the periodic table in science at high school, but I can still remember some of it. Let's see what I can remember. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, and I know there's a ton more than that, but that's about as good as I can do.
No, you're doing very well. Back when I was at high school, I remember our science teacher made the whole class write out the first 20 elements, and if anybody got it wrong, then you had to do it the next day, and the next day, and the next day, until we all got it right. So that's kind of ingrained in the memory, I guess.
So 20 elements, that's still nowhere near how many there are on the periodic table.
No, that's true. At present there is 118, and there may be more in the future, as you will learn, I guess, as this podcast goes on.
So are these all natural things?
Define the word natural. That's a very interesting word. But if in terms of natural you mean found on the Earth, then most of them are, but some of them are not, and some of them are actually synthetic, which means that they're made in the laboratory.
Now, the periodic table, if it was invented, who was the inventor?
A guy by the name of Dmitri Mendeleev, he gets the credit for inventing, and I'm doing air quotes here, the periodic table. In fact, he gets the credit for being the first person to publish his version of the periodic table, and that was in 1869. There was another contemporary of his by the name of Lothar Meyer, who essentially came to the same sort of conclusion as Mendeleev did with respect to a periodic table. Trouble is, he didn't publish before Mendeleev, and in science there's definitely no silver medals.
Now, I'm a zoologist, so I tend to think of things in terms of the tree of life. And, you know, the tree of life helps categorise things in nature. So, in a sense, the periodic table is to chemistry what the tree of life is to nature, isn't it? But when Mendeleev was putting it together, did he have a complete jigsaw puzzle? Did he have all of those 118 pieces and he could go, OK, now I just have to arrange them to make the picture?
Oh, no, not even close. And I guess that was part of the great genius of Mendeleev, is that he was sort of working with an incomplete deck, if you will. At the time that he published the periodic table, just over 60 elements were known. And he's got these chemical elements and he's trying to make sense of them. He's trying to put them in some sort of order. And he eventually sort of puts them in orders that relate to their chemical reactivity, how similar they react to each other. And he found that sort of groups of three elements would sort of tend to behave very, very similarly. So he grouped them together. And eventually he sort of figured out that if he did this for a whole lot of elements, he would end up with his version of the periodic table, which compared to our ones today is woefully incomplete, I guess.
So he left gaps, but we have filled those gaps in, and was he right with those gaps?
Yes, he was. And again, the absolute genius of the man, he recognised that not all of the elements had yet been discovered. And the way he did it was that he figured that there were going to be gaps in his periodic table where unknown elements should be. And so he said, right, well, I'm going to leave a gap here because I realise that this element hasn't yet been discovered. It will be one day. And what he could do from his version of the periodic table was to make remarkably accurate predictions as to the properties of these unknown elements. And this was really quite extraordinary.
Now, all of these elements, their properties are to do with their fundamental structure. It's been such a long time since I did chemistry. Could we do a Chemistry 101, please?
Oh, absolutely we can. Okay. And the first thing that we need to know is the definition of an atom. And an atom, to a chemist anyway, is sort of the fundamental building block of nature. And in nature, there are only 118 different types of atom. And from those 118 different types of atom, we can construct not just a planet, not just a solar system, but the entire universe. So everything in our known universe is made up of combinations of those 118 different atoms.
So they're like the ingredients in the ultimate recipe.
Absolutely, yeah. So an element is a substance that's made up of a single type of atom only. Okay, for example, the first element on the periodic table, number 1, is hydrogen. And hydrogen is made up solely of hydrogen atoms. Helium is the second element. It's made up solely of helium atoms.
And so on and so on.
Oh, no, I'm not going to do the whole thing. No, yeah.
Oh, phew.
Well stopped, yes. But we say that the atom is the fundamental building block. It itself is then not actually indivisible. We can divide the atom up into 3 fundamental components: protons and neutrons and electrons. So an atom is made up of what we call a nucleus. In the nucleus, you've got these particles called protons and neutrons, and that gives the nucleus the positive charge. Protons are positively charged. Neutrons, as the name suggests, are neutral. And the electrons around the outside, they are negatively charged. And we get this idea of the atom from over 100 years ago now. The great New Zealand scientist Ernest Rutherford came up with the structure of the atom through his famous gold foil experiment.
Tell me more.
Gladly. So Rutherford was working at a time where the existence of atoms had only just been really confirmed. And this was the early years of the 20th century. And what he did was to take a very, very, very thin sheet of gold foil, very, very thin, only a few atoms thin. And he shot these very, very energetic particles at this gold foil. And he just thought that the particles would go straight through. But he was really astonished to find that these particles that he shot at the gold foil, which were positively charged, most of them would go straight through, but some of them would be deflected a little bit, and some of them would be deflected a lot, and about 1 in 6 or 8,000 or so would bounce straight back towards the source. And he couldn't believe this, because these particles were so ridiculously energetic, and the gold foil was so ridiculously thin. He then thought, right, there must be something really, really massive in there and really highly positively charged. And that's the way he came up with the idea of the atomic nucleus, which contains most of the mass of the atom.
Rutherford was an amazing scientist. He was our first Nobel Prize winner too, wasn't he?
He was indeed. He won the Nobel Prize in 1908 for his explanation of how radioactivity works. He didn't get it for splitting the atom, but radioactivity had only been around for about 10 or so years before he got the Nobel Prize. So it was an unknown phenomenon, and he came along and he explained that radioactivity was essentially a breaking up of the atomic nucleus. It's the nucleus is too big, essentially, most of the time. And in order to stabilize itself, it starts spitting out particles from its nucleus, and in the process, it generates these very, very high energy particles which are dangerous. And this is why we think of radioactivity as being not very good for us. But in this series of podcasts, we will find out that there are times when we can use radioactivity to our advantage.
The periodic table, all of the elements have got, like hydrogen is H and helium is, from memory, is He. They also have a number. What's the significance of that number?
Okay, you'll see hydrogen listed as 1 and helium listed as 2, etc., etc. And that's a thing called the atomic number. And the atomic number is related to the structure of the atom in that it tells you how many protons you've got in each of these atoms of that particular element. Okay, so hydrogen has got 1 proton, its atomic number is 1. Helium's got 2 protons, its atomic number is 2. Uranium's got 92 protons in its nucleus, and its atomic number is 92.
Is that also where the adjective light and heavy comes from? So something's a light element, something's a heavy element?
Yes, indeed. Yeah, we talk about light elements, literally, I guess, like hydrogen and helium, which are so light that they float off into space. They're not heavy enough to be retained by the gravity of the Earth. We talk about heavy metals, not only in a music sense, but also in a chemistry sense, things like lead, mercury, things like that.
What kind of chemist are you, Allan? Apart from a very enthusiastic one, obviously.
Oh, goodness me. I'm a coordination chemist, which means I generally work with things called transition metals, which are, as the name suggests, metals, and they make compounds that have got gorgeous colours, and they can be used in all sorts of materials. They're very, very useful compounds.
So we'll come across them.
We will certainly talk at length about these in coming episodes.
In terms of this podcast, we're going to be mixing things up a little bit. We're going to do it alphabetically. There'll be something that's familiar, then something that, we might never have heard of,
yep,
and something very unexpected. So that's going to be an exciting way to do it. But anyway, this was Elemental, a podcast from RNZ, and you can find us at rnz.co.nz/ chemistry.
You can subscribe to the podcast for free at all of the usual places: Apple Podcasts, Spotify, Stitcher, and Radio Public.
We'll be back soon with episode 1 of Elemental, which is going to be what, Allan?
That is going to be the first element on the periodic table alphabetically, which is actinium.
Fantastic, but until then, it's goodbye from me, Alison Balance.
And goodbye from me, Alan Blackman.